Hello students, welcome to the video lectures of software engineering. Today we are going to talk about the test strategies for conventional software. So a conventional software approach to software testing follows a systematic strategy that can be applied to traditional software development process. So the strategy typically includes what? So one is planning, next is test design, next is test execution, bug reporting, verification, and validation. We all will go through all these things. So now the testing, we all know that it's the process of running a program to find some errors before we deliver it to the end user. So the main aim of testing is what? We make sure that the software is working correctly and it is meeting all the requirements, performing well, and also which have a good quality. That's what our objective is from the testing, right? So next, so strategic approach to conventional software testing. So a strategic approach to conventional software testing involves planned and systematic process for ensuring the quality. Okay, so now we see what is the strategic approaches. What are these? So it includes, first one is formal technical reviews. Second is component level testing to system level testing. Third one, relevant techniques at each stage. Fourth one is involvement of developers and independent testers. So fifth one is separation of testing and debugging. So what are all these things? So first one is formal technical reviews. So we are talking about the strategic approach to conventional software testing. Okay. So first is formal technical reviews. So basically we conduct these reviews called as formal technical reviews to find out the errors. Okay, in the very early stages of our development. And next one is we component level testing to system level testing. We start testing from small parts that are called as these components, and then we test how they work together as a system. And the third point, relevant techniques at each stage is nothing but we make use of different testing methods depending on which stage we are falling in. Okay, so involvement of test developers and in testers is nothing but both the developers and the testers, all these people will do the testing. Okay, then in separation of testing and debugging, nothing but this is just to make you clarify about the testing and debugging. Just you have to remember that testing is to find the errors or finding the errors. Debugging is fixing them. Okay, so the just remember these are two different tasks. Okay, if let me write. See, testing is to find errors. Debugging is to fix them. Clear. So these are all the strategic approach to our conventional software testing. So there are various levels. We talk about those now, various testing levels. Here you can see in the diagram, unit testing, integration testing, validation testing, and system testing. Okay, so what are all these? So unit testing focuses on individual components using white box techniques. Okay, integration testing is it combines components and test interactions. Validation testing is this ensures the final software meets the requirements. System testing is it verifies that software works correctly with other system components. Clear? So this is about the testing levels. So just the name you can see here, it is written as spiral model because you can see the spiral structure. Okay, just we have to you can imagine the software process as a spiral, and it starts from planning and move outwards through different levels of testing. Okay, that's what the diagram shows you. Okay, so let me again reiterate the things. First one is unit testing. Okay, where it is individual components or modules. Next is integration testing, which tests how modules will work together. Then it's about the validation testing, checks if the built software meets the requirements or not. Then it's system testing, which tests the software as a part of the complete system. Clear? Then test strategies for object-oriented software. So object-oriented software requires specialized testing strategies due to characteristics like encapsulation, inheritance, and polymorphism. So then what are these key strategies, test strategies? Those are given below. So unit testing, integration testing, validation testing, system testing, regression testing, object-oriented specific errors to detect. So we'll talk one by one. So first one is unit testing. So what it is? So focuses on testing individual classes in isolation. Goal, it's this verify the correctness of methods, attributes, and interactions inside the class. So what's tested here? Okay, interface, whether the class accepts correct inputs and return expected outputs or not. Okay. So what is this unit testing? Let me clear you. Okay. So basically unit testing is called, the very first step, and it is performed or done for each small unit or module of the program what we have. So it uses these white box testing methods where the code is visible to the tester. That's what your white box specifies, right? So what does this test, or what does this checks is like like so input or output flow, this checks. Okay, and internal data it checks, and it also checks the boundary conditions. Okay, and helps for error handling. Okay. So these are all, the things what this particular unit testing checks. So what are the common errors that we found here are, these things, wrong arithmetic logic, wrong initialization, precision issues, incorrect loop or conditional logic, and type mismatch in comparisons. Okay, these are the things what we find as a common errors here. Clear? So then how do we perform is just we use some drivers, where we call them as main programs, to just call the module being tested, and we use some stubs kind of thing, fake modules we say. So just to replace the components that are not yet ready. So by doing this, we just set up our unit testing. Clear? Then we talk about integration testing. What is integration testing? Combine unit, sorry, combine unit tested classes or modules and test them as group to check how they interact. What are the approaches? Big bang approach, incremental integration. Okay. And the incremental strategies, we have top down integration and the bottom up integration and sandwich integration. So what are these things? We'll see. So basically the integration module, this will combine all the tested modules to build the full program. So the main goal that is already described here, that is it checks if modules are working well together. Clear? So then coming to the approaches, we have top-down approach. Okay. So what happens in top-down approach is nothing but, this will start testing from the main module and slowly moves down. And this also uses the stubs. Okay. This uses the stubs to replace the lower modules. And here you can see it's mentioned, starts with the main class and replaces lower modules with stubs. Okay. So the only issue is, yeah, here you can see pros are test high level logic early. Cons are requires many steps, may miss low level issues. Yeah, that's what the problem is. It is hard to test the high level logic, without, the real low level modules, we can say. Okay, that is what top down approach is. Next one is bottom up approach. So when I say bottom up approach, it's given here, starts from atomic classes. Okay, build upwards using drivers. Pros are test detailed logic early. Cons are complete system view is delayed. So means what? So this will start, from the very lowest modules and combines them into clusters and uses drivers for the testing. So eventually what happens? This will remove drivers and connect to clusters. So the problem here is the full program does not exist until the end. Okay, that's the issue. Next is sandwich integration. So combines both strategies. Pros are reduces need for stubs or drivers. Cons are needs careful planning. Right. So when I say the sandwich integration, this is, it's a mix of the top down and bottom up approaches, precisely to say. Okay, where the high and low level modules are tested together, and this reduces the need for too many drivers and stubs. So next we talk about validation testing. So validation testing, what is this validation testing? We'll just try to see. So goal of this validation is it's check if the final software meets the customer's functional requirements. Okay. So let me clear you this. We have some needs or the requirements of the customer, right? So this validation testing will check whether the final product what we are delivering will meet the customer needs or not. Okay. So previously we discussed where it uses the white box testing, right? So now white box testing in reference to unit testing, where in unit testing I have an approach of having this white box testing. Now coming to this validation testing, we make use of what? Black box testing. Okay. So here we use black box testing, which means that the tester does not look at the code. So what does this ensure? Is, all the functions are working and the system is behaving correctly and performance is acceptable, and whatever the documentation that we do is correct. That's what the activities here are mentioned. Test all functions and behavior described in the SRS, the software requirement specification, and also ensures the performance or documentation requirements are met. So if everything works, okay, software is accepted. Right? This is the result. If not, defects are logged in a deficiency test. So types are alpha testing and beta testing. So alpha test, it is done at developer side with user participation. Beta testing is done at customer side without developers presence, which means this alpha test is done at developer side by the participation in this by the customer. Okay. Beta is done by the customer's place. It is done at the customer's place by actual users. Okay. So in this kind of, beta testing, we don't have developer presence. Okay. The developers are not usually present at this particular point. Okay. Because it is done at the place where it is going to work. That is at the customer's place by the actual users. That is beta testing. Next, we talk about system testing. So now the software is tested as part of the full system with hardware, users, and other components as well. So the objective is test the software as part of the complete system, including hardware, databases, and users. So the key tests here are recovery testing, security testing, stress testing, performance testing. What does this say? Recovery testing is this will check how the software recovers after the failure. Okay. Security testing is to make sure unauthorized access is not possible. Stress testing is this will push the system beyond the normal limits because this just it tries to test when it the load is increased. Then we have sensitivity testing, performance testing as well, which test sensitivity testing is which uses tricky inputs to find the weak points, and performance testing is to test how fast and efficient the software runs under the increased load. So now the focus is integration with other systems, elements, user environment, and overall behavior. That is your system testing is all about. Then we talk about regression testing. Okay. So what is regression testing? Purpose: rerun previous test cases to ensure that recent code changes have not broken the existing functionality. The recent code changes. Okay. So every time we add or change something, we must check if the existing feature is still working or not, or any issues that have been raised. Okay. This is called as your regression testing. So this includes the all the general test of all features, and these tests focused on changed parts and also tests around the changed modules as well. That's what it is saying. Critical tests that exercise core features, tests around areas where changes occurred, tests for recently modified components. So the benefits are ensures new code does not introduce the old bugs. Clear? So in this we have next is smoke testing. So what is smoke testing? Smoke testing is an integration testing approach that is commonly used when shrink wrapped software products are being developed, which means like it's a quick check to see if the new build of the software is working or not. Okay. That is what smoke testing is. So the smoke testing approach encompasses the following. First one is software components that have been translated into code are integrated into a build. A series of tests is designed to expose errors that will keep the build from properly performing its function. Then the build is integrated with the other build and the entire product is smoke tested daily. Got it? Which means this will create a software build with necessary files, and it runs the basic tests to find the major errors. Clear? So we do the smoke testing daily during the development activity. Okay. So that we just can reduce the risk when we perform the integration, and also we can check the progress, how far we have been achieved, and also it ensures a reliability in the end product also. Okay, that's what the use of your smoke testing. Next we talk about validation testing. So validation succeeds when software functions in a manner that can be reasonably expected by the customer, right? So validation test criteria, software validation is achieved through a series of, black box tests that demonstrate conformity with requirements. Next, system testing. So like the software is incorporated with other system elements and a series of system integration and validation tests are conducted. These tests fall outside the scope of the software process and are not conducted solely by the software engineers. Okay, which means now the software is tested as a part of the field system. Okay, so now under this system testing, you can see we have recovery testing, security testing, stress testing, sensitivity testing, and performance testing. We already discussed. Recovery testing checks how the software recovers after a failure. Security testing is, make sure, let me write here, recovery testing, nothing but this checks how the software recovers after failure. Security testing makes sure unauthorized access is not possible. Stress testing, this will push the system beyond the normal limit. Okay, sensitivity testing is uses tricky inputs to find weak points. Performance testing is this will test how fast and efficient the software runs under the load. So these two earlier points we discussed in our previous slide, but the sensitivity testing, performance testing is discussed now. Hope you understood, students. Thank you.